Okay, so now what I'm going to do is that I'm going to go over all of the questions in the practice final given to me by someone, and largely they should be the same concepts except just with different numbers, right? So, question one. Let A, hold on, let me just, okay, question one. A is a positive integer set, which is less than 7, and B is a binary digit. So, A is basically 1, 3, 5, right? It is anything that's a positive integer, so more than 0, and it is an odd integer that is less than 7, but it says less than, not less than or equal to, right? So it's not this, it's only this, which means it doesn't include 7. And then B is a binary number or a binary digit. And a binary digit is basically 0 or 1. That's it. Alright. And it says here the set A union B is equal to. Now, union, right, means that it includes everything, right? So, union, so if I have two Venn diagrams here, right, it'll include everything. Compared to an intersect, which looks like this, right? It only takes the common values. So that means set A union B equals 0, 1, 3, 5. And the reason why it is not 0, 1, 1, 3, 5, the reason why it's not 0, 1, 1, 3, 5 is because in a set you have no duplicates, right? So this is A union B. So I'll just now which of the following represents a tuple? So let's go through these step by step. So of course it is A. The answer is A, right? I'll highlight it. Uh, okay. So why is it A? So in Python or in any normal programming language, this is a tuple. This is a list or a set. Sorry, no, this is a list. Sorry, this is a set or a dictionary, right? Meaning it has no duplicates. This is a list. And then this is an absolute value, which in normal mathematics basically means a positive integer only, or when it comes to sets, it means that it is just the number of items inside inside the list, tuple, dictionary. So, for example, for D, there's 1, 2, 3, 4. There are total 4 elements, right? So the answer is A. Brackets, just normal brackets is a tuple. Now, if set A has 12 elements, what is the cardinality of its power set? And if I recall correctly from the cheat sheet, a power set is basically just this squared. So 2 to the power of 12, which is, let me just, 2 to the power of 12, 4096. Let me just quickly confirm it because I do not have the cheat sheet. So yeah, I was correct. It is 4096. Now, for this one, this is a bit of a long one, but okay. It says set x is equal to any positive integer that is less than or equal to 70, which means it is 1, 1, 2, 3, 4, blah 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 up until 70. And then for y is the integer t, 60, which any number between 60 and 75, but it says but it's not equal to. So it's 61 to 74 because again it's not equal to. So the set is 61 blah 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 up until 74. So now we'll proceed to the question. So what is x minus y? X is basically this set subtracting the elements from this set, right? Meaning, what is common between both sets? Well, what is common in set X, it goes to 70. In set Y, it starts at 61 and goes to 74. And what it's asking here is that give the result set for which X's set is subtracting the values that is in the Y set. So it'll be from, instead of 1 to 70, you're moving from 61 to 74, right? That means it's going to be 1 to 1, 1 to 3 up to 60. So it is option number 3. And now, for number 2, it is the intersect. So what this is, which is a XOR, right, like this. And an XOR inside a set basically is an intersection, right? So it's just this, right? And now it has the absolute, which means how many items are inside the intersection of x and y, which is 4, right? I would say not 4, 10, right? From 61 up until 70. So it is 10 elements. Now, y minus x, right? That's basically as x minus y. You're going to set y and you remove the common values that are in that are in x, right? So go into set y and then you remove the values that are in set x as well, right? You remove the common values, and what you're left with is the remainder of y, right? The best way for me to show this in a Venn diagram is that it will be drawn like this. And you will remove the shaded part. So x, y. So you want to remove x, right? So remove all the components of x, and all you're left with is y, which is 71 to 74. Let me just make it more prominent. And now the amount of items inside x union y, which is everything inside x and y, which is total 74, right? 1 to 70, and then basically since it's common from 61 up until 70, it's 1 to 70, then 70 to 74, which is a total of 74 values, right? So 6, right? And then for the total number of items inside inside X. That is 70, which is 1, right? Because there's 70 items inside table 1, right? And then now for the last part, why not? The total number of variables, or the total number of items, which is common between X and Y, right? It just wants the amount of total, like how many items there are in here, right? If we go back to here, in here, which is a total, which should be 74 as well. Oh, sorry, no, not 74. Uh, hold on. I have realized I have made a mistake, right? When it comes to number 2. So if I go, which is the second option. So if I just erase it, let me just. So XOR, which I made a mistake in, is actually not the intersection. It's basically everything but the everything else. So you remove everything else but the intersection, right? Basically, you're only giving what is common, if I recall. So that would mean it would not be. It would be. Let me just check. 1 second. Okay, so what XOR is that you're basically removing the intersection, right? You're only removing the common items, which I made another mistake in. So if I just, you're only removing the common items. So anything between, so from 61 up until 70 remove. So there's only 60 items. Okay, so okay, the best way for me to illustrate this would be, so it would be from 61 to 70 would be removed. So they're only left between both sets, by the way, right? So imagine you put everything like into a Venn diagram, right? And you take out the common, which is 61 to 70. That means you're left with X equals to 1 all the way to 60, and then Y is 70 to 74, because the common has been removed. So now what it wants is basically the total summation of the items that are not common, which is 64. I have made a mistake. That was on me. And then now for X intersection Y, that should be 10. So because X intersection is just what you want from the inside, right? From here, right? So it's 10, right? From 60, from 61 up until 70. So yeah, 61 up until 70. Now let f be a function from set A to set B, where A is 3, fb equals to 2, fc equals to 1, and fd equals to 3. Which of the following is correct? So the f inverse. So okay, for this one, the answer should not be that complicated, right? Because if fa and fd equals to 3, so right, so if I go back here, so if fa and fd equal to 3, that means the inverse, which is basically saying turn, like, just swap the positions, right? Which would become f3 would be a set of a and d, because if you look at the examples they've given, fa has 3, fa is common to 3, fd is common to 3. I think it's called image, right? It is called the yeah, it's basically if it maps to the function of 3, so to a. So the answer to this is B. Okay, so now to question 6. Floor x squared multiplied by ceiling x squared, right? And since there are no decimals here, you can literally just ignore the floor, and it's x squared times x squared. But then if you understand basic math, if you multiply with a variable that has a power to it or a square, these get added. The powers get added. So it's reality, it's x to the power of 4. And when it comes to squaring or using something that has to the power of, right? The negative becomes a positive because a negative and a negative multiplied a negative gives a positive integer. So minus 2 to the power of 4 equals to minus 2 to the power of 4 equals to 16. And when you're doing it in a calculator, you have to put this in a bracket, right? Because if you don't, it'll give you a negative integer, which is wrong. And then minus 1 to the power of 4 is 1. And then the same can be said to 2 to the power of 4 and 1 to the power of 4, which equals to 16 and 1. And now, because this is a set, you see these are duplicate, right? Because this is a set, you cannot add the duplicate data. So all you have to do, right, is just 0, 1, 16. It's preferred in that order. And now, set A, B, C, D, and the set B, 1, 2, 3. Let let function A go into function B, being described as FA equals to 3, FB equals to 1, FC equals to 2, and FD equals to 1. Which of the following best describes the function f? Now then, so a function is a one-to-one, means that it's an injective, right? Injective means that no two elements have the same value, which is incorrect because B and D have the same value of 1. So this is wrong, right? And now a surjective means that everything at least has one value, or at least every value has been used once, which in this case is true because 3 has been used, 1 has been used, and 2 has been used. Duplicates doesn't matter, right? So it is an onto. So the function is not a one-to-one function, but rather an onto. So it is this, the third option. Just Now, what does that mean? This is an injective. An injective means that there is no duplicate maps with the same value. So if there's only 3 in set A, so ABC, it would be an injective. It would be a one-to-one function, but not an onto, right? Or it would just be a one-to-one, right? That would also happen to be an onto function because all values have been at least used once. But in general, if A has 3 values, so if A equals to let me just put in a different color so you will understand. So if A equals to A, B, and C, and then B, of course, equals to 1, 2, 3, and then, of course, F, A, F, B, and then F, C, which equals to, of course, 1, 2, 3. This is a one-to-one function that is also an onto function because a one-to-one means that every object inside every item inside the set has been used at least once. And there's also an onto function because every item, sorry, I had it mixed up, sorry. It is a one-to-one function, meaning every item is unique, right? There's no duplication. So it's all like fd is one as well. So that's a one-to-one. And then a surjective, which is an onto, means that it is used at least once. So, but since FA, FB, and F, so since there's a duplicate, this is not an injective because it's been duplicated. So it's a surjective, right? But then now you're going to ask, can an injective be a surjective? Yes, it can, because the rules dictate that in injective it has to be unique, right? There's no duplication. And then a surjective has to be means that everything has to be used at least once. So this example is injective and surjective. But then an example of an injective only that is not a surjective would be this, right? C doesn't have a value assigned to it, right? So it's injective because there's no duplicate data, but it's not surjective because not all the data has been used. Okay, so now this is inversing functions, right? So f of x equals to 2x minus 3. And then now you have to make an inverse function, which is f minus 1x, which for me, the easiest way for me to understand it is that I will turn, because f of x can be written as y, right? So y equals to 2x minus 3, and then I just make this x the subject, which would be y minus y plus 3, because the common rule would be that if you switch something to the other side, its operator will be flipped. So a negative becomes a positive, a multiplication becomes a division. So then now, if I move the 3 to the other side, I will get y plus 3 equals to 2x. And then now I'm going to divide both sides so that I get rid of the 2 here, but then I add the 2 here, right? So then these 2's will be cancelled because a multiplication and a division will cancel each other out, like how a positive can like wipe out a negative number. So now x is equal to y plus 3 over 2. And then of course you switch it back because for the function, so it's just f minus 1, and then this is of course being x. Again, you don't that way the way I did it is how I was taught, and it's what's most easier for me to understand. And now for the real question, right? Now that I've inversed the function, it says f inverse of t. This is a trick question because they are both the same. But then if you change the name of the variable, which is from x to t, you just do this. That's it. So it's 2 plus 3 over 2. Let me just that's it. It's a bit of a trick question. Now then, S is a bit string of the length 3 for question 9, of course. Now we're in question 9. So S is a bit string of length 3, which means it's an octal, right? Because that's what we're taught. And then T is just that, but it has at least two ones. So I'll have to do it in a separate area. So this is basically 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and then of course 1, 1, 1. right? So that'll be total 8 values. So 1, 2, 3, 4, yeah, that's 8. And then now for t, which must have at least two ones. So it's 0, 1, 1, 1, 0, 1, and then 1, 1, 0, and 1, 1, 1. Now, what is the total number of values inside S? That is 8, because, you know, it's including everything, right? It just wants how many items there are inside the set of 8, and the set of S. Now, what is the power set of S? That's basically 2 to the power 8, right? 2 to the power of 8. 256. There are 8 items, you know. T is T is 4, right? 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. And now it's saying for part 4, right? Define two int x, so all the items inside t, right? Convert it into an integer, and then show the elements of ft using the roster method. Now, the roster method is just discrete structure jargon for putting it in curly brackets, right? Basically, put all of the elements inside t, convert it into an integer, right? And then put that inside a set, which is, of course, just convert this to, which is uh, 3, this is 5, this is 6, and this is 7, right? So it's literally just that, and then you put it into a set right here. So 3, 5, 6, 7, of course, and then now for the last one, it's basically saying, so what this means? This means sigma, right? So sigma means sum, right? Add everything together. So now it's just telling you, add everything, in the value of x that is inside which is inside the function of t, which, as you can see, we've done here, which is just 3, 5, 6, 7. So if I do that on the calculator, 3 plus 5 plus 6 plus 7, which is 21. Now, a geometric progression. Geometric progression, the formula is a0 equals to, give me a second. So the function is that a0, sorry, it should be, if you pardon me, it should be an equals to a0 times r to the power of n. What does this mean? An is basically what you want, right? A0 is the first term, which is 2. R is the common ratio, which is 3. And then, of course, n is the term index, right? The term index meaning which one do you want, which is n, which is number 2. So let me reiterate. So a0 equals to 2. R is 3. N is 2, because n is the number you want to get, right? So it is quite literally 2 times 3 to the power of 2. And if I do that on my calculator, that should give me 18. Now for number 11, right? Given which of the given circuits is equivalent to the following combinational circuit, right? So this is basically, okay, x goes into a NOT gate, it becomes x complement. Same thing happens to y complement. Put them together in an AND gate. It's now x complement times y complement, or just xy complement, x complement y complement. And then, of course, it's going to now pass through to another NOT gate, which means it's going to be x times x complement times y complement over, and then, of course, one more complement. And following De Morgan's law, the x complement is removed, right? Because it cancels each other out. But then, of course, upon cancellation, because everything is now being inversed, right? It is now the multiplication here is going to become a positive into an addition. So the final should be x plus y, right? It's this option, right? So I'll go scroll down so you can look at the options. There's x plus y, x x XOR y, x multiply y, and then of course x plus y complement. Okay, now this is now what is the valid sums of products? Sums of products is basically the midterm, right? The midterm is when you where the output is 1, right? And so minterm is written as a lowercase m, which equals to 1. And then, of course, there are 6 options. Yeah, 6 options. And then, of course, obviously, sigma m, I think, hold on, I'm just going to do the working out, right? So, let me just, okay, so upon further inspection, so what the answers are is that so of course, this is one of them, right? And then this is the other one, which makes sense, right? Because I have X, Y, and Z. And then, of course, this one, because this is a full midterm, right? Where this is 1, 0, 1, 0, sorry. So this is 0, yeah, 0, 1, 0. Sorry, wait, no, I made a mistake there. 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. The reason why this is incorrect is because it doesn't have y and z. This doesn't have x. This one's fine, right? This one's fine. This is missing x. This is missing y, z. This is not a sum of products. This is a product of sums, right? Where it's basically looking for 0, not 1, right? Because this is, a product of sums. Now this one, right? Write a combined function f, g, x, y, z. The simplest way for me to put this into terms you can understand is put it in a set and remove all of the duplicates, right? And of course, this is a max term, right? Max term, capital M. I made this mistake where where I forgot to put the capital, right? So what the answer is that it is M0, M2, M3, M6, M7. Because M3 is twice, once here, one here, right? So remove the duplicate. Now, evaluate FG101. 101 is basically, let's see, this is 4 plus 1, 5. That is false. It is not there, right? There's only 0, 2, 3, 6, 7. So this is 0, right? I don't know why it won't let us say false, but it is 0, right? So if I go back, if I just look at the question again, Yeah, so I made a mistake here. So with max term, right? So if 5 is basically saying, is 5 there? Yes or no? It's like, yes, it is not there, right? And then evaluate FG111, right? So it's saying, is it there? And you're saying, no, it is not there. So yeah, I know. It's confusing, really. But the best way for me to say it is that if it is inside the set, put a zero. If it is not inside the set, put a one, right? Saying is it's like saying that. Anyways, so the best way for me to say it is that is 5 inside the list? Yes or no? And then since max term is just the opposite of min term, yes, no means one, yes means zero, right? So it's like yes int. Hold on. Yes int and no no's, right? So is 5 in there? Yes, it is not. And then is 7 in there? No, it is. It's confusing, but like once again, if you practice more, you'll get it. Now, minimize the following Boolean function. The easiest way for me to look at this, because there's two ways you can do it. There's the long way, and then there's the short way, right? I prefer to do it the long way because it will help me understand. So if I'll just take some of this real estate here and here. So I separate it into two parts. This and this, right? Separated by the plus. So x, y, z plus x, y, and z. So y is this. So x complement is here, z is here, but the only thing that changes is y because there's y complement here, and then of course normal y here. So then that becomes x complement z, and then bracket y complement y. So, and of course, the normal rule is y complement, a complement, right? Complement plus a normal number will equal to 1, right? So it's x, z. So now then, x complement z, and then multiply by 1. 1 multiplying anything by 1 does not change anything, so it's just x, z. And now for the next part, right? X, y, z plus x, y, z. It's the same as the first half, right? It's y complement is the only thing that's different, so you take that out. Because y complement, because you can then compress it, right? Y complement plus y equals to 1, right? So it's literally just x, z times 1. And then now you're down to x complement z plus x, z, right? And now you just take x complement and x out because of course these two are changing. You can further compress them down to z uh, time z x plus x, which equals to, of course, z z times 1, which will leave the final answer to be z, right? Now, what is the absorption law? So absorption, I don't have access to the cheat sheet, so I genuinely can't uh, like find out the answer. but I will do my best to give a guess. If not, I will pull up my version of the answers because I did the practice final. But what I do know is that absorption is basically like compressing and then uncompressing it. Let me just see which one is. Okay, so the absorption law. So I'm going to be honest, I do not know what the ruling, how absorption law works, but what I do know is that the answer is this. So yeah, x, y, x plus z, and then this as well, and then, oh, sorry, no, no, not that. Is it? No, no, it is, it is. And the last one is uh, x bracket y, z. Okay, hold on, what? Wait, okay, hold on. X, y, x, xy plus a plus xy, and x, y plus z plus z. That will give, yeah, okay. So then, and then the last one is xy plus z. I'll try to figure out how the absorption law works, but from what I'm getting, right? Yeah, I don't get absorption law. Now then, the K-map, which I have briefly explained, right? So there's, okay, so I'm gonna zoom in. I'm going to write down tiny xy, right? So x, it's yz, my bad. And of course here is being x. Now then, if I'll do it in different colors. So if you see here, they can only be done in either cubes or like this, or in the very rare chance like this. That of course is in the rare chance, but so now, as you can see here, so we'll take care of this big red box first. So as you can see here, if y is 0, right? Because look, all you have to do is find what's common, and then that's the answer, right? So like look for a common pattern. If x is 0, it gives an output of 1. If x is 1, it still gives an output of 1. That means x is not the answer. So we'll go over to here. If y is 0, the answer is 1. But then if y is 0 again, the answer is 1. So that's already 1. And then if you look at z, if z is 0, the answer is 1. If z is 1, the answer is still 1. What that means is that regardless of the value of x or z, what it all matters down to is y. Because y is the only value that does not change, that still gives an output, right? And since it does it, when y is 0, it is going to be y complement. Now, for the one in green, what this means is that if y is 0, uh, if x is 0, it's going to be 1. But then as you see here on the bottom, it does not make a full square. right? So if y is if x is 0, it will give an output. So uh, x 0, because if x is 0, it will give an output. And then look, if z is 1, it will give an output, right? So that means it's just normal z. So the answer is y complement plus x complement z, which is this one. I'll see if I can highlight it. Now then, how many edges are there in a bipartite graph? In a complete bipartite? The answer is uh, 13 times 24 over 2. That is for the edges, if I recall, which should be, if I go through, let me just give me a second, please. Yeah, so it should be 13 times 24 over 2. 13 times 24 divided by 2, which is 156. And now the reason why it's 156 is because it says edges, right? Edges, it's a two-way edge, right? One, two. One here, one back, right? So why is it only 156 when it should be 312? That is because one edge is just one direction. It's just telling you what's one way. Like, just give me. They don't matter if it wants there and back. It just wants there, which is why you have to divide it by 2, right? So they only want one, not both edges. So you remove that one, right? And then you only have one way, right? Which is, of course, divided by 2, right? 2 remove 1, divide by 2, which is why it's 156. Question 18. The type of undirected graph may have multiple edges connecting to the same two vertices, but no loops are allowed. That, I believe, is a mixed graph. If I recall, because, and I will get to my reason shortly because I'll have to write it out. So I will pause for a second, I will come back. Okay, so after I've written down my answer for myself, my own notebook. So a simple graph doesn't allow so yeah, it doesn't allow multiple edges or loops, right? No multiple edges or loops. A mixed graph, right, can have can have both undirected and directed edges, right? But they're not relevant here because loops are allowed, if I'm correct. Yeah. So since a mixed graph can have both directed and undirected, it can also have loops. But then it says here the type of undirected, so it only wants undirected only, right? Not relevant because it's asking for only undirected. And then of course now a pseudograph, right? A pseudograph allows is allows multiple edges, allows multiple edges and loops, but it says here, no loops allowed. So it is a multigraph. Now, question 19. How many edges are there in a complete graph on 28 vertices K28? That is basically uh, 28 minus times 27, because it's just this times this minus 1 over 2, which is 378. How many ones are there in in the agency matrix of a K24 graph? I think it's, if I remember correctly, it's just 24 times 23, but you don't divide it by 2. So it's 552. Now then, okay, for question 21, it may seem confusing, but it isn't. It's not that hard, right? Degree just means how many edges are coming to D, right? So there's one here, another one here, and then of course three here, right? So sorry, 1 plus 1 plus 3, right? That is 5. N here just means neighbors. So how many is it neighboring, right? That's just B, A, B, E, right? Because it's connecting to A, B, and E directly. So you have to write as a set. So just A, A, B, E. And a simple way for you to get this question correctly, if it says multigraph, it's multiplicity. If it's like pseudo, it's gonna be like pseudo something, right? But either way, it's just literally, if it has the name in it, that's the answer, right? It's multiplicity. I don't know why, but I'll just if it's the correct answer, it don't matter. Now then, for question 23, right? In an undirected graph G, the edge E is incident with the vertices U and V. Which of the following are valid statements based on the above information? Choose all that apply. So edge E adds 1 to the degree of U. That basically means there is a line. The edge E makes a line coming out of vertex U, right? Like this. So U, U, V, E. So now the edge E adds 1 to the degree of U, meaning there's one line coming out of U. So U and V are adjacent. That is true as well, right? Because you know, sorry, because of course U is connecting to V via E, so they're connected and they're nearby. The edge E is called a loop, right? That because it's undirected, it is a loop, I think. No, 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 it isn't. but U and V are connected by E, right? But according to my answers, it's saying all of them are correct, which doesn't make sense. I'm thinking that they were just lazy about it. But anyways, the values of a set of domains determine an n-tuple in a relation. The Cartesian product of these domains is called it is a composite key. Because a composite key, how it works in databases or relationships, is that it's two foreign keys become primary keys. And those two primary keys have multiple different sorry have multiple different sincere apologies. Okay, so back to the question. Master key and joint key do not exist, right? They are not terms in a relationship in a relational database. So it's literally either a composite key or foreign key. But it says here, but a foreign key is basically the primary key of another table is the primary key of another table becomes a foreign key in another table, right? That's what a foreign key is. So, by saying the Cartesian product, Cartesian is of course every possible combination. And the only way to get every possible combination is if you have a composite key, because a composite key has more than one primary key. Okay, this question is a bit long. The poset. The easiest way for me to understand it is that for poset, if I go back to my notes, a poset. Okay, now in the posets, right? I have to go back to my notes. Okay, to find the total number of pairs, the formula is n times n minus 1 over 2, which is basically 5 times 4 over 2, which equals to 10. So there are 10 possible pairs, right? And what you have to know is that a comparable pair is basically if it can be divided, right? There's of course 1 divided by 3 and 3 divided by 1, right? And between the two numbers, if at least one of them gives a full integer, right? Instead of 0.333 reoccurring, which is 1 over 3, if it's 3 over 1 gives 3, that is a comparable pair, and that is a answer, right? So so you immediately get one. So 1, 2, 3, 4. Yeah, you immediately get 4, right? Because 1 goes into everything. So that's 4. 3 goes into 6, and 3 goes into 9, right? Plus 2, right? 3 does not go into 4. 4 does not go into 6. 4 does not go into 9. So there are six comparable pairs. And to get the incomparable pairs is just the total possible number of pairs subtracted by the total comparable pairs, which is 6, which is the answer is 4. And if I go back to my notes, that should be correct. If I go back. So I hate how easy the questions are. Look for it. I can't find it. Okay, but you just take my word for it. But it is 4. It is 4. Now, which of these posets is in total order? It's this one. Because total order means everything has a comparable pair, right? 6 doesn't go into 8, right? 4 does not go into 9. 5 does not go into 8, right? One will go into 2, 6, 8. Two will go into 2, 2 will go into 6 and 8. 6 will not go into 8. 1 will go into 2, 4, 9. 2 will go into 4, but not 9. 4 will not go into 9. 1 will go into 2, will go into with 49 vertices. How many leaves are there? The formula for this is that L, which is leaves, equals to M minus 1 times 14 times I plus 1. Which, if I go back to my notes, so I will explain the formula. Okay, yeah, I am correct. So M. M is basically the number in an emery tree, right? M-ary, right? Emery. Minus 1 multiplied by I, which is the internal vertices, plus 1. So it is 14 minus 1 times 49 plus 1, which is 13 times 50. But I like to write the full equation, just in case. Times 49 plus 1 plus 1, 638. Postfix. How to work out postfix. So prefix is when the the operand, like minus, plus, multiply, divide. So prefix is before everything else. Postfix is after. So if I zoom in, right? Or in fact, no, I have plenty of space. Yeah, I have plenty of space. So so 39 will be done in the area of 40. So 5. So look, you can see here 5 1 minus, and then 5 5 plus. Right. So let's start with that. So 7 5 minus 1 4 plus 4 10. Right, multiplied plus. So 7 4 4 4 4 10 this, and then 7 plus 4 is 11 plus, and then there's 40 plus, which is now 51. Right? Simple. It's not that hard. Prefix is basically if this plus. Prefix is if this plus is behind here. Now, consider the following tree T. Which are the children of B? C E F. It's just the children, not the children's children. It's not like I'm asking for your grandchildren. I want, like, it's like there's dad, children, and then grandchild. The dad only wants the children. He does not want to see the grandchildren yet. So it's C E F, right? C E F. Find the vertex. Find the level of vertex M. So M 0, 1, 2, 3, 4. So it's 3. The height of the tree 4. What is the arity M for this emery tree? So the arity you can easily find out by basically looking at what is the maximum amount of leaves can a tree have, right? The maximum amount of children a parent can have. And in this case, it's 3. It's 3. I know that because if I go to, what am I erasing? If I go to here, look, there's 1, 2, 3. 1, 2, 3. 3 is the maximum because everything else is either 2 or 1. So it is 3. Considering the following binary tree. Okay, it says infix. Infix is basically normal mathematics, but in a tree, you go from bottom to top. So x equals to 8, y equals to 4. So it is basically 8, so I'm starting from here, right? So it's 8 times 4 is 28. 8, y equals to 4. So x times y equals to, so it is uh, 4 times 8 equals to 32, and then 8 plus 32 is 40, right? And then 8 over 4 goes to 2. That means it's now 40 plus 2, which equals to 42. So it will be, so here will be 32, 8, 8, 4. Then this will be 8, 4. That means here would be 40. Here would be 2. Then add them together, you get 42. Thus, 42 is your final answer.